Hello everyone, this is KP the Math G once again for you today. This is the 71st video that I'm going to do. This is my 70th one earlier this morning. Now we're working on 71. Hopefully my battery will stay alive long enough for me to do it. But if not, I'll charge it up and we'll go at it again. We're going to talk about a volume of revolution. This time we're going to do the washer method. And in this particular problem I have y is equal to the square root of x. I want to revolve this about the line y equals -1. Now recall that from the last video that when we did the disk method we did not have a hole here. In other words, when we revolve this around the x-axis, we didn't revolve this one, but something like this about the x-axis, there is no hole. All right, it is a solid, is what it is, a solid of revolution. Some people call it the disk method. Some people call it a solid of revolution. Either way, all right. But now this is going to. Let me show you what it's going to do here. Let me get this right here. Alright, now I want to take this isolate interval here. Alright, right there. I'm going to go all the way down to -1. Alright, right there. That's it. Right there. And what this is going to do is, okay, this is going to make a circle. Alright, I don't even know if I can make one big enough here, but it's going to make a circle here. And it's going to go around here. That's going to be a hollow circle right here, but this one here is going to be more, okay, let's see, more like that, and it's going to go on down like that. So you have a solid part here and you have a hollow part right in here. It's going to be hollow and it's going to come down like this, I believe. Let's see, this is going, I think it's going to do something like this. Let me see if I can get a, alright, so let's see, it's going to do something like, let's see, alright, it's going to do something like that right there, and it's going to make it's going to form a washer. There's going to be an empty spot right in here, an empty hole, a circle right in here, okay? But I'm not good at drawing circles, as you can tell, but I try to make it oblong so you can see the outline of it as good as possible. But this thing's going to rotate around this axis right here, okay, and it's going to go out right here, but it's also going to leave a hole, well, 1 inch or 1 foot or whatever you want to say, hole right here. Alright, so what we have to do is we have to figure out, there is a little rule that we need to look at when we're talking about this, when we talk about leaving a hole. Now again, from the last video, this was pi. I'm going to go on an interval, in this case from 0 to 4. Alright, now r squared. But now when you have a hole, you have the big radius minus the smaller radius, and since we are perpendicular, you know, even with the x-axis here, alright, we're going to say delta x. Okay, now the big radius is from -1 all the way up here. We know that this height here is y. Okay, we know that this height is how much? Well, from 0 to 1, how much is that? Now don't say -1. It's not that distance is not negative. It's positive. Okay, so keep that in mind. I know you're not going to say -1, but that's what I would do. Oh, that's -1. No, it's 1. Okay, so this distance right here from here to here is 1. This distance right here from here to here is y. So all of this, the whole radius, this big radius here, is equal to 1 plus y. Now we're going to square it after a while, but 1 plus this y gives us this entire radius. This big radius here, this is radius r, big R. Alright, the whole is right here. Alright, so the whole is how much? So that's little r. Little r is going to be where the hole is. Alright, that hole right here, that's going to be 1. Now, granted, I mean, if we were going around the x-axis, we wouldn't have a hole. But since we're going around x equals or y equals -1, we're going to have a hole right here. That's 1 unit wide. Alright, the radius is going to be equal to 1. So here's what we're going to do. We're going to integrate now. Integrate pi. Now, capital R. Okay, so actually from 0 to 4. 1 plus y, but y is the square root of x. And we're squaring that. Keep in mind that you got to change that y to the square root of x. Alright, now we're going to take away that little radius, which is 1, and we're going to square that. And my cat is coming back in here to try to learn a little bit of... No, he's not learning any calculus. He's just going through the doors. Okay. Cats can't learn calculus, can they? Alright. Alright, anyway. Bad joke. Alright. Anyway, that's where we are. Now, we got to square this binomial, don't we? Okay? So let's erase, do a little erasing here. Alright, let's see here. Oh, where's my eraser? Okay, never mind. I will just erase it with this. Oh, here it is, right here. Alright. Alright. I'm going to square 1 plus x. 1 plus the square root of x. X. 1 plus the square root of x. X. 1 plus the square root of x. Alright, so 1 times 1 is 1. Remember, y'all might be used to that FOIL method. 1 times the square root of x is the square root of x, so plus the square root of x. Now, square root of x times 1 is the square root of x. Some of you may already know to double that anyway. Square root of x times the square root of x is the square root of x squared, but that's just x. So the square root of x squared is just x. So here we got this. This is 1 plus 2 square roots of x, isn't it? Alright, so here we go. From 0 to 4. This is 1 plus 2 times the square root of x plus x minus 1 dx. Alright, there it is. The idea is knowing that this is going to form a washer. It is because it's not going to rotate around the x-axis. There's more. There's one more hole right. It's going to leave a hole 1 unit, okay, thick. Okay, 1 unit, a radius of 1, whatever that is. Okay. Alright, so now 1 minus 1 is gone. Alright, so now we're just left with this. Alright, so 2 square roots of x, and of course remember dx on the end. Alright, now I'm going to erase some of this because I'm going to need room down here to work the problem. So let's go ahead and erase this right here. Alright, now let's see, I want to rewrite this square root to x to the 1/2, and remember the square root of x is x to the 1/2. So I still wrote that out, I'm just writing it in exponential form, okay? Alright, there it is. Alright, so let's see, we got to integrate now, so this is equal to pi times 2x, I'm going to leave a little times something, x to the, now remember 1/2 plus 2/2, gotta add 1 to that, that's x to the 3/2, and remember we flipped that over to be 2/3. Alright, so 2/3 here. Alright, and plus, this is to the 1, so I'm going to raise it, so x squared over 2, and I'm going from 0 to 4. Alright, we can do this, we can kind of fix this up a little bit, so pi, alright, 2 times 2 is 4, so 4 over 3. Alright, x to the, now this is actually the square root of x, the square root of x, and I'm going to cube that answer, plus x squared over 2. Alright. Alright, right there. And again, we're going from 0 to 4. Alright. Ooh, we're running out of room here, so let's erase this up here at the top. We don't need this anymore. So I have a problem on the back. The reason I don't flip the board over is I got a problem on the back. So let's go ahead and just want to try to put everything here. Let's get a different color. Alright, see if we can do that with that. Alright, here we go. Alright, I'm going to try to squeeze everything right in here. Alright, so I'm going to plug in the 4. So pi times 4/3. Alright, the square root of 4 cubed plus 4 squared over 2, and then minus, if we plug 0 in here, 0, the square root of 0 is 0, all of this is going to be 0, and 0 squared is 0, so this is actually minus 0. I'm trying to save some space. I hope you can see that if I plug 0 here and here, that all of this is just going to be 0 here. Okay? Alright, so let's see. Square root of 4 is 2. Alright, so 2 cubed is 8. So pi is 4/3. Alright, so this is 2 cubed. So 2 cubed is 8. Alright, plus 4 squared is 16. 16 over 2 is 8. Alright, like that. Alright, and then this is going to be pi times, alright, 8 times 4 is 32. So 32 over 3 plus, and since we got to write this in terms of with a denominator 3, we might as well multiply 3 times 8 and get 24 over 3. Okay, let's put our answer right here if we can, right in here. Alright, the answer is going to have a pi in it. Alright, let's see, it's going to be over 3. So 2 plus 4 is 6, and 3 times 2 is 5. 56 over 3. 3 will not go into 56. So 56 over 3 pi. And that's how you set that one up here. So again, just very briefly, this whole thing is the big radius. You're always going to have a big radius squared minus a smaller radius squared. When you have a hole like this, that's what you're going to have. So the big radius is 1 plus this y. This height here is y. But y is the square root of x. I had to square that. Now minus 1 squared. So if anything you need to do is get this part set up correctly. Then once you do that, then you can square this and then subtract that 1. You're left with this. Integrate. Plug in the 4 and then the 0, and you got it. Okay, that's really how you go about doing this type of problem. Okay, 56 pi over 3. Alright, let's look at the other one here. Hopefully this will be a little bit simpler. Alright, and this one, you know, when you have a hole, alright, you just realize you just gotta see that right here. Where is my hole here? I'm going to rotate this about x equals 3. This part right here is solid. This part right here is not solid. This is my hole. And you got to recognize what part is solid and what part is the hole. Now, what part is all the radius? Big R is this. Alright, let's put big R. Big R, little r. We're going to subtract off because we're going to have a hole. We're going to rotate this about x equals 3. It is bounded by this line y equals 8. Bounded by the curve. Bounded by x equals 0, which is the y-axis. Okay. Alright, so the solid plus the hole is the whole thing. Alright, so you want to do that. Add those two up. That's your big R. Alright, so how much is this? This whole length is 3. The solid part is x, which I know we gotta solve for x. This part from here to here is x. So what does that leave the hole? Alright, this part, if this is 3 and this is x, if this happened to be 1, if x was 1, then 3 minus 1 is 2, right? The rest of it would be 2, right? Alright, so this would be 3 minus 1. Alright, well, if it's 2, 3 minus 2 is 1, okay? So 3 minus x is this whole. Alright, so I recognize the whole. It is 3 minus x. Okay, this is x. We're going in the x direction this time. Okay? Alright, now, the radius, the big radius, is how much? Well, that's from 0 to 3, that's 3. Okay, the big radius is the solid part plus the hole. Alright, so that is 3. Alright, now, the deal is, this is perpendicular to the y-axis, which means that we must solve for x. Okay, because the absolute interval is perpendicular to the y-axis. Alright, so let's solve for x. If we take the cube root, both sides, we know that the cube root of y is equal to x. Alright, so in place of x, I'm going to put the cube root of y, which actually I'm going to write it as y. Oh, let's lower that. That's getting crowded. Alright, so r is equal to 3 minus, this is a 1. Alright, so y to the 1/3. Alright, so the big R, that's our pi. Don't forget that. Now we got to figure out what our, what we're integrating from and to. Alright, from 0 to 8. This thing can go, this bar, this oscillative interval can go from 0 to 8. And we're saying big R squared minus little r, and we're going to square that. And instead of y, this, remember, this is delta y, so we got to make this dy. Delta y means this is dy. Okay. And that may be the way you find out. Okay, you're going to use this. This is delta y, so this is going to be dy. So I need to solve for y. Okay. I need to work on that. So give me some room up here. Let's see. Ooh. Alright, so let's see here. 3, I'm going to have to erase it. So 3 minus y to the 1/3 times 3 minus y to the 1/3. Alright, so I know I'm going from 0 to 8. Alright, I know 3 squared is 9. Now I've got to figure out what goes in here. 3 times 3 is 9. 3 times y to the 1/3 is y to the 1/3, but that's a minus. So that's a minus 3y to the 1/3. I need something that will make that darker. I got another minus 3y to the 1/3. And I've got y to the 1/3, y to the 1/3. All you do is add the exponents. Negative times a negative is a positive. So y, don't get those signs mixed up now. So y 1/3 plus 1/3 is 2/3. 2/3. So 2/3 dy. Whoa, all of this. Alright. All of this, now I'll stick the dy on there. I'm going to have to give me some new markers. They're getting faint on me. I'm going to distribute this. This is now actually this is -6 right here. So right here it's going to be pi from 0 to 8. 9 minus 9 plus, alright, 3. -3 is -6. So -6 y to the 1/3 plus, oh, minus, wait a minute now. This was minus here, but when I distribute the minus, this will be plus here. Okay, minus 9 plus, alright, yep, and then this will be minus here. Minus y. We do not, at this point, want to mess up with our signs here. 9 minus 9 is 0. So we're really left at this with this right here. Alright, I already knew that 9 minus 9 is 0. Now, let's erase this rotate about x equals 3. Alright, we just want to integrate this now. Okay, now we're going from pi. Alright, integrating now. 6. Now remember, we've got to add 1 to that, so 3/3. So that's actually 1 plus 3 is 4. Alright, so 4/3, 6y. Oh, I need to the 4/3. Now remember, I'm making this 3/4 right here. Alright, remember we flip that over. Right, y to the 4/3 here. Okay, and then add 1 to 2/3. So 3/3 plus 2/3 is 5/3. So minus y to the 5/3, and we're going to flip that over, and that's going to be 3/5. And we're going from 0 to 8. And again, this is actually the cube root, so if you mind, I'm going to just go ahead. This is the cube root. This is the cube root of y raised to the 4th. And this is the cube root of y raised to the 5th. Cube root of y raised to the 5th. Okay. Alright, now, here we go. Pi, 6 times 3 is 18. This is 18 over 4. Well, actually, we could reduce that. 2 goes into 4 2 times. 2 goes into 4 2 times. 2 goes into 6 3 times. So 3 times 3 is 9. So 9 over 2. Alright. And then now the cube root of 4. We'll raise that to the 4th. Minus 3/5. Alright. This is the cube root of 8. Wait a minute, now I need to put 8 in here, not 4, 8. Alright, now that's right. 8. Raise that to the 5th. Okay. I'm just double checking. I'm going slowly because I like to double check. Alright, so equals pi. Now let's see, 9 halves. The cube root of 8 is 2. So all this is 2. So 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is all 16. Alright, 3/5. Alright, so let's see. The cube root of 8 is 2. 2 to the 5th is 32. 32 over 1. Now remember, if we plug the 0 part in there, alright, that is going to be just all zeros here. Alright, so minus 0, like that. Okay, well, where to put our final answer? I guess we can put it up here, can't we? Alright, so pi times, let's see here, 9 over 2. Well, let's see, 2 goes into 16 8 times. So 8 times 9, 9 times 8 is 72. So 72. Alright. Unfortunately, 5 won't go into 32. So we got to multiply across. So 3 times 2 is 6. So minus. Yeah. 3 times 2 is 6. 3 times 3 is 9. So 96 over 5. I got to make that 72 in terms of 5, so something over 5. So let's see, 72 times 5. 5 times 2 is 10. 5 times 7 is 35, so 360. So this is pi times 360 over 5 minus 96 over 5. Alright, so let's see. The battery's still holding up, so let's keep going. So 360 minus, a lot of work here, minus 96. 10 minus 6 is 4. 15 minus 9 is what? 6. So 264. So this is equal to 264 over 5 pi. There it is. Woo! Okay. But the idea is learning how to set it up I believe you can easily, hopefully you can easily find a derivative, but just setting this up. 3, alright, that's the entire thing. This part needs to be subtracted off. This is that whole, so 3 minus x. But x happens to be y to the 1/3. Alright? We squared that. We squared that. We got down to this. We integrated and plugged the numbers in and got 264 over 5 pi. Okay. Whew! That's kind of exhausting, isn't it? I hope that you followed me well here, at least to some